Hi everyone, let's start lecture 3, Introduction to Predictive Analytics. This lecture will be presented in two parts, and this is the first part. On the course map, we are still in introduction part, and this lecture 3, is the last lecture in introduction. So we are going to have an introduction to predictive analytics. What's predictive analytics? In one sentence, it is predicting future using the past data. So we are going to use the past data, the historical data that we have, and then based on that, we want to predict the future behavior of the system. Okay. For example, we can predict a customer's lifetime value, CLTV. So this measure usually is applied in business to business environment, not for the individual customers in retail industry. It's not applicable. But in business to business environment, since the number of customers are limited and they have long-term relationship with the company, so based on the past transactions and behavior, we can actually estimate or predict a lifetime value for that particular customer. Okay. Or another example could be product recommendation capability. Yeah, based on the past behavior of the customers on purchasing the goods, if a new customer is picking a particular brand or a product, then based on the past behavior, the system can recommend other products with maybe the same features or with complement features and so on. So the system can recommend other products to the customer. Okay, so again, this can be done by predictive analytics methods. Or another example, forecasting the next quarter's sale. Okay, so this is obvious is a forecasting model, and using the past data we can forecast the future's demand. And usually when we have predictive analytics and we are predicting the future, usually we use those predictions in our decision making. For example, if we are going to prepare a promotion plan for our sale in the next quarter, so by having the forecast of demand in the next quarter, we can optimize our promotion plan. Okay. The first thing in applying predictive analytics methods is having a good historical data. So without having a good historical data, we're not able to use predictive analytics methods. Okay. For example, let's say we want to predict what customers will buy in future. Okay. So in order to answer this question, we need to have these data. Who are buying? Here we mean we have segmented our customers. So what segment is our focus now? And what they have bought in the past. So the past behavior, the past purchases is the key data here. Okay. And the attributes of the purchased product. So here, if we know that what are the attributes of the purchased products in the past, then we can build an attribute-based prediction model. So based on the attributes, the system can recommend other products to customers as well. Okay. And also, it's much better to have the demographic attributes of the customers, like gender, age, residential region, socioeconomic status, and so on. So based on these demographic data, we can segment our customers, and then based on the behavior of each segment, or we can recommend common products to a new customer who belongs to one of the segments. Okay. And in case of having multiple channels with customers, we need to ensure that the data are gathering in all channels are consistent. Okay. The second thing after having a good historical data is the statistics. So here we may have applied descriptive analytics to describe our data, and we may have some conclusion and insight on our data now. So now it's time to figure out which statistic method can be applied here and for what purpose. For example, uh, let's say we have a data set of the purchases and our customers, and we have a hypothesis here that a set of independent variables like age, gender, or the demographic attributes. These are correlated with the purchase decision of customers in one segment, for example. So by having this hypothesis, we can apply regression analysis here to see if really there is a correlation between the independent variables and the dependent variable, which is purchase decision here. And let's assume that the regression analysis finds yeah, there is correlation. There is correlation between those independent variables and the purchase decision, which here we assume it is a dependent variable. And based on that, a regression model is built here. Now we can use the regression model, equation and coefficient, in order to predict a score of the likelihood of a customer to buy a certain good. So based on that, if there is a new potential customer from that particular segment, then this regression model can predict its score, and if this score exceeds a threshold, then the model will offer that product to that new potential customer. So as you see here, this is how predictive analytics, for example, in this example works. So so we need to have knowledge about the statistics and the capability of the models and the features, and then based on that, and also on the other side, based on the data that we have, we need to obtain some hypothesis, ideas, and based on that, we should apply appropriate statistic method. The third thing about the predictive analytics is the assumptions. So we know that every model is built based on some assumptions. For example, here in predictive analytics, we assume that the future is going to be like the past, right? Because we are going to predict the future based on the past data. So our assumption is this: the future is going to be like the past. So, but you know that sometimes the customers' habits change over time. If that's the case, then that predictive model is no longer valid, because we are not able to predict the future based on the past data, because the behavior has been changed. So if we have a predictive model that has been built several years ago, then we should be careful about the assumptions, and we should make sure if the assumptions are valid. Another risk here for predictive analytics is ignoring a key factor. And that key factor has changed significantly over time. For example, let's say the time that we are building a predictive model for predicting a mortgage payment, the housing prices are flat and there is no chance to have significant decline in housing prices. But it is possible, right? It is possible, and if we ignore this parameter, this factor, and if prices fall in future, then that predictive model wouldn't be valid anymore. So beside checking if the assumptions are valid, we should see if we have ignored a key factor in our model or not. So these are the main questions to validate if our predictive method is still valid. So the first question, what is the source of data used for analysis? Are the sample data representative of the population? Are there any outliers in data distribution, and what are their impacts on the results? What are the key assumptions for the model, and what conditions may make the assumptions invalid? So by answering these questions for any data set and for any predictive analytics, we can make sure if our assumptions are right and they're still valid, and we can rely on the results obtained by that predictive method. Okay. So in order to have a successful predictive analytics, first, we need to make sure that we are gathering right data. Okay, the source of data should be appropriate. The sample data should be representative of the population, and also we shouldn't have missing values. For example, data should be clean and so on. Okay, so gathering right data, and then we need to make sure that we're considering right and valid assumptions. Okay, right and valid assumptions. Here we can consult with the experts that have experience on that business and also have knowledge. So those opinions would be would be so helpful for us. Okay, and then we need to apply the right statistical model. So here you need to have a statistical knowledge. So without having knowledge on statistics and without knowing the features and the properties of each statistical method, you're not able to apply the right statistical model. Okay, so these are the main thing in order to make sure that we are doing right in predictive analytics. Okay.